Okay, this is Zoom Thursday, April 23rd, 6:30 p.m. for heavy civil construction. And if you would, please go to Vanco Hall, go to Soils Info folder, click on that, and then it is ET Geotech case study. It's the first one that you're going to see. I take it you can see my my laptop here?
Yes, sir.
Okay, so go to this. Actually, I am already in it, so I'm going to, and it should look familiar. Everything in my life revolves around ET, the movie plus the building. So this is a geotech case study that I used to do in construction materials when I taught that way back in the day. And again, if you just joined us, go to Vanco Hall and go to Heavy Civil, go to the Soils Info folder, and go to ET Geotech case study. And the MEDA book, the textbook, does a nice job in chapters 11 and 12 on site work and soils and excavation, because that's what we're talking about. I suppose real quick, the masonry test for this course is tomorrow night. I do apologize for having to move it to Friday. That was my mistake. You've got a 4-hour window to take it from 7 to 11. Once you start, you then have 2 hours. It's a 1-hour exam. I've given you 2 hours within a 4-hour window. But if you start it at, say, 10 o'clock, you've only got an hour because the exam shuts down at 11. So just keep that in mind, if you would, please. And I think you're able to go back and forth between the questions, and you won't see a grade until after the exam closes at 11 p.m. And I'm not exactly sure how it grades it. So if the grade looks really out of whack, just relax till late Thursday night or early Friday morning, and I'll send out an email. Okay, so that's for that. Now, I did say in my last, or my email today, talking about this Zoom lecture, I mentioned that our next Zoom is Monday night. That's not true because you've got a surveying test Monday night. So my thought is to have a Tuesday night Zoom for heavy civil. Okay, because again, Monday night you have a surveying test. So Tuesday at 7:30, it's actually after another one of my lectures. It would be if you needed help with what we go over today. So I'll put that in an email probably either tonight or tomorrow morning. So keep that in mind. Just remember about the surveying test. So you'll see emails from me for both this class, heavy civil, and construction surveying. So we've got 21 participants. There's the ET. And so usually I always like to start teaching soil testing right off the bat, but we've got to go through a little bit of background information as to where the soil testing starts in the process. And they talk a little bit about that in chapters 1 and 2. We'll talk about the pages that you want to look at there. There's ET. Everybody knows it. You've built it. It's a pretty cool building. How to read the plans, we went over that. This is actually an update I just saw earlier, so I figured I'd throw that on there. All of these you've already done, so nothing is, let me get this out of the way. Do me a favor and let me know if somebody is trying to get into the class, okay? So these are all just how to read the drawings. Again, this is very similar. It's identical to what you saw in surveying. But now instead of the surveying, the layout aspect, we're going to take a look at the soils. that the soils testing that was done before ET was built. So this is what that area looked like. There's the refrigeration center before they put up the new, they got a new facelift. Used to be just a concrete block, and then they used that commercial stucco, and the brand name is called Drive It. And that's what it looks like now. This is what it looked like before. So basically just a field out there, and they put in a monitoring well and soil boring. I got to fix those text pages. Those are wrong. It is page 242. This is text page 242. And on page 2 of the text, they do talk about a surface investigation and a subsurface investigation. You have one entire course on surface investigation. What course is that? It's surveying, right? A survey is a surface investigation. A subsurface is, what's underneath ground level, okay? And this is what it looked like a few weeks later, almost from the same angle. So they basically carved out a huge shelf. They carved this out, and this is the subgrade for the bottom floor, which would be all the laboratories of the ET building. And this is what we've been covering in concrete. I can't wait to get you back to pour that damn concrete so we can get building in the fall, looking towards the refrigeration building. Here's actually where you can see the facelift going on for the refrigeration building. That was the same time, construction was during the same time. So how did the project start? Okay, we talked about reading the textbook, the figures. This means paragraph. This little symbol right here. On page 2, they talk about 5 project delivery phases: pre-design, design, construction, commissioning, and startup. You're not going to see any test questions on that in this course, but you'll see it in the fall in commercial construction. Now on page 237 of chapter 11, there they talk about the subsurface investigation. So here's some reading that I want you to do, 238 to 242. If you don't have the book, I'm going to be giving you enough handouts that you'll be able to take the exam for soils, which is going to be during the week of May 11th. I'm thinking that our surveying final, which is actually surveying test number 2, will be Monday night, the 11th. And we'll probably, why don't we do this Thursday night, the 14th? Gives you some time in between. Think about that. If that does not work, then we've got a couple of weeks to, I'm writing myself a note. We've got a couple of weeks to adjust that, okay? It's going slow, but it's going fast. So I want you to read these pages, soils and site work activities. Then you've got pages 245 to 257, earthwork grading. SOE is support of excavation. That's when you have deep excavations and you don't have the room to step back the excavation. We'll talk about that. We'll talk, because of the situation now with online, I'm not sure how much we'll learn about this, but we'll learn a lot in commercial construction, because a lot of commercial construction deals with supportive excavation. Slurry walls, secant walls, and so on. And some of you have taken commercial, so you know what I'm talking about. Okay, so now you got an idea about the soil testing done at the pre-design phase. And let's see, go back to the top and circle the monitoring well. Well, this is if you were here at Delhi Tech. We're going to talk about soils handout number 1. And I got to change that chapter. So this is what I want to show you. This is a drill rig that was taking soil samples for a future bridge project near Delhi. And this is out actually by Falls Mills. where that pull-off is, and all the fraternities, paint those rocks. That's just a little bit past this little brook, bridge over a brook. And so I stopped by, and they let me take pictures. So to do those soil investigations, the borings and the monitoring well, they're going to get a drill rig like this. And they basically drill into Mother Earth or Father Earth, and they take samples to a depth that the geotechnical engineer, which is a specialty of civil engineering, the geotech engineer says, I want soil borings down to 40 or 50 feet. When we went down to the JFK expansion years ago, they were going down hundreds of feet. And so they grab, let's see, I got to admit somebody. So they grab these samples, and you can see this drill rig is quite high. And this shows the device that comes apart in two pieces to capture the soil that is not rock. It's called a split spoon sampler, and it's basically pounded into the ground. And here's a YouTube with no audio showing how they do that. So this is augered into the ground. It's actually within a drill. And then the samples are then put in containers to prevent evaporation because they want to know the moisture content. Okay, and then here's in Delaware County, the rig will eventually drill through rock, and here are some samples that it captured. The driller's holding rock that had a seam. Okay. The split spoon sampler cannot be used for rock. Drilling is required. So here are the samples of rock that came out of the that boring out by Falls Mills. Okay. And then here's a drill using diamond bits. It has an inner casing where the water is pumped to keep the bit from overheating. Okay, so the inner casing, this is what's getting you the rock, if you will. So the split spoon sampler is pounded into the ground, and then they'll grab samples at various elevations, depths below surface. They'll get a surface elevation, then they'll get depth below surface, so they could actually get the elevation at any point below ground. So all of this soil goes back to the geotech, and they create something called a boring log. Okay? So figure 11.5 on page 242 of the text and page 9 of this handout. And here it is. So view, rotate, view. Okay, so you're going to have some questions on this. So here is the monitoring well that you saw in test boring 1. You saw that in the original picture. And the monitoring well is to find groundwater. And then here's all your test borings. And here's the refrigeration building. The road is right in here. Okay, and then here's the plumbing building. So guess what? All of these test borings have northing and eastings and elevation at ground. And then there's the monitoring well. It's called MW. TB is for test boring. Okay. And
Are we given what depth the boring is taken at?
Yeah. So you'll see that, where is it here? Okay. So I think I've got to add one more page. Yeah, I got to add one more. Let me make myself a note. I thought I had it. So add test borings. And let's see, size description, relative properties. Yeah, I got to take another look at this. I thought I had both pages. So let's go back to right here, the monitoring well is near test boring, right? We already said it was TB1. So these questions are going to be let's see, B7. These I think are going, I've got to update this, but they're going to be due, I was thinking if we had these due, Tuesday night at midnight, at 11:59. Just this page right here, and I'll write this on. So I'm going to get you log board B7. If not, I'm going to use chapter 11. I'm going to use this. This is out of the textbook. Come on, get out of there. So this is a typical boring log that's in the textbook. Okay, so you've got your, this is surface, right? So this is 0. You're going to go 5, 10, 15, 20, 25, and so on. We'll get into all these symbols.
Excuse me, Mr. McKeegan.
Yeah.
Bianca's in the waiting room.
Thank you. Appreciate it. So here's where the samples were taken. We'll talk about the penetrometer, the penetration, core removed, liquid limit, plastic limit. All of this we're going to go over in depth in the next 2 to 3 weeks. So you basically can say what kind of soil you have from ground level all the way down to the end of the, they went 50 feet down. And then there's your water level. So that's where they actually hit static. It's what they call a static level. Okay. So that was at about 35 feet of depth. Okay. So that's a soil boring. So what you're going to have are a series of questions on those. And again, I thought I had B7 on there. If I can't find it, then I'll rework these questions to correspond to this soil boring. Okay. And I'll have that due Tuesday night. So you can look it over after your surveying test, just look it over, come up with any questions, and then we can go over that Tuesday night. You can submit that. And then you're going to have another soils homework due probably Wednesday night, or could be Thursday morning. But we'll talk about that. So let's see here. So here's coordinates, particle size for cobbles. We'll talk about this Tuesday night. Now, the blows on a sampler, it's what they call the N value, okay? And that gives a rough index of the soil density and strength. So number 9, the answer is density and strength. And then the text got a little wacky here, but the test is called the standard penetration test. So the rough index of the soil, density, and strength, because what the geotech engineers want to know is how strong is the soil. Now you've seen examples of what they call a heavy or a deep foundation for heavy civil. What was the type of deep foundation that you saw? We didn't talk about it that much. It was right before we left. And it was those pile foundations. So that meant that the soil couldn't handle the load of that building near Boston. a typical, the house that I'm in, 10-inch wide wall, 20-inch wide footing, more than enough for the loads that this house is going to exert on Mother Earth. But if the soil is weak, then you're going to possibly go to what they call those deep foundations, piles, caissons, spread footings, and so on. So again, that N value is a rough index of the soil density and strength, and it's called the standard penetration test. Okay. Now, this one, I got to change some things here, but I'll send just this page out. I'll redo the PDF, but then I'll send out just this page with a bunch of hints. Okay. And again, this is work that's done in the design phases. The designer hires the geotech almost like a subcontractor. The designer will hire a civil engineer, a structural engineer, a mechanical engineer, and so on. So as part of the civil engineer would then potentially hire a geotechnical engineer. And then this is all you've seen in surveying, so we're not going to go through that. There's a picture of those retaining walls for ET. That this one is buried, and this one they tore out. Okay. And again, there's this is on page, what the hell page is that? Page 11. Okay, we talk more about the subsurface. They talk about plans and specs. Right, you've already seen that. The soil data is part of Division 2. Remember the master format. What was the division for masonry? The index. What was the index number for masonry? How about concrete? Ooh, you might want to know that.
Concrete was 4, masonry was 5, right?
You might want to check that out for tomorrow night, but that's just me. That would be a hint. So they generated a new index about 4 or 5 years ago. Division 2 used to be soils. Now Division 2 is existing conditions. And Division 31 is excavation. Okay. And then it's all about the language. Mind the gap, that was always a fun thing I could tell you about. And if you're taking the subway in London, as you get out, they say it so nicely. They say, mind the gap. In Brooklyn, they'll say, watch the beep, beep gap between, the crack between the car and the subway platform. So it's all about language. Okay. So now we're going to talk about the soil tests that are run on those samples. And then that helps the geotech come up with a foundation design. Okay. And then we talked about the reading on earthwork. And, but here, the soil that we tested, not just in design stages, but in the construction stage, have to be classified. This is critical. This is on page 12. This is a big part of your test during the week of May 11th. Again, everything we're going over tonight is not on the test tomorrow night. Tomorrow night is just masonry. Okay. So why do we classify the soils? We've already answered it. We determine if the soils can be used for the specific project. So if you're building, let's say you're building a pond for somebody in the Delaware County area, and all your soil is gravel, right? No way. Thing's going to leak like a sieve. Let's say you're building a road and you hit into a bunch of clay. Well, that's not good for a road. So that's why you classify the soils, to determine if we can use it for that specific project. And the specs will tell us. there, you'll see up here, it says, these are the specifications for the, these are the specifications for the ET project. Okay, so you got ET, and then you've got some federal specs. And then and this is dry stuff. Oh my God. But is it important? Then you got DIA is for Denver International Airport, or do it again. Went from a $1.9 billion project to a $5, a slight cost overrun. So there's some specs from Denver. And then I think I threw in some, no, I didn't. I've got it on another handout. We've got some New York State specs. So we'll get into that. So again, why we classify, determine if we can use it. And then the second answer is, how can the soil deal with the loads? Is it a building, road, bridge, tunnel, etc.? The tunnel that's going under the Hudson River as we speak, which is a bypass to the Delaware Water Aqueduct, which is leaking. For that tunnel, they've hired 2 geologists full-time. They have to know the strength of that rock that they're tunneling through. So the load is critical. The drainage. How well does it drain? Again, if you're putting in a pond, you want clay. You want it to hold water. And then frost action. That's always an issue here. Okay. So examples of why we classify soils. We don't use gravel or sand for an earthen dam. We don't use clay as backfill against a foundation, because the clay absorbs water and expands, and it'll push against that foundation. And we're going to talk about 4 classification systems. The USC, which I just showed you, it's the federal one. Federal soil classification. Unified soil classification, not University of Southern California. Hey, what time is the football draft on tonight?
8 o'clock.
Okay, we'll be done by 8. Actually, I could give a damn, but I'm so bored. It's like, Jesus, I got to watch something. DOT, New York State Department of Transportation. Kind of a hybrid was the Denver project. We've got there's a cool case study there. Okay. This is also on Banco. Right? That's a model of the Denver airport. That's not where they put the airport. Okay. That's where they put the airport. Hey, that is the concrete graveyard. Remember I told you that they had to rip out 20,000 cubic yards of concrete. That's where a lot of it went. So the, damn that phone. I turned the volume down too. So the land northeast of Denver is this prairie where the deer and the antelope roam. And then there's one of the concourses. Oh, I thought I had that volume down. Let me just, so resume recording. So here's the concourse. That's where they park the birds. Here's the runway in the distance. So we're going to cover all of this as to how they dealt with soils. And then just some cool pictures that we'll go through. That's Royal Gorge. Just like to show that. You've seen that before. There's the paving lane of a runway, the pavers. And here's the soil specs. So we'll talk about that if we have time. And then there's the soil cement, where it's all clay. And so what they do is they lay down a blanket of a lime slurry, and then they take this $250,000 rototiller and they rototill it into the ground. That's what they're doing right there. So that takes all the plasticity out of the clay, and then they compact it with a sheep's foot roller. So we'll talk, and then here's some of the other tests. So that's where they actually break. They take a sample of the soil and they actually break it in compression. And then here's some of we're going to study this in terms of the field testing for compaction. Okay, proof rolling. And then we're going to walk you step by step. And then here's a field density test. So here they actually jacked against this dump truck to see how strong the soil was. So that's the other one that you want to take a look at. Okay, and then AASHTO is highway construction. Okay, so AASHTO is for federal highway. We're just going to do a quick discussion. Okay. Now we're going to classify soils inorganic versus organic. All of our soils are inorganic. We do not care about landscaping. That's nothing against the landscapers. They make a lot of money, but we don't deal with it. That's just the final product for the lawn. My motto is pave it and paint it green, as you know. I don't mow my lawn until probably the first part of June. With this weather, it won't need it till July. We're going to use a sieve test and a hydrometer test for what they call grain particle size. And then there's also a plasticity and liquid limit test. Did anybody get a chance to look at the Norwegian clay slide? That was a marine clay. That's one of the YouTubes that I asked you to look at. Okay, so these are all engineering properties that we're going to talk about. And then here's some cool soil pics that we've seen through the years. This is on, one of our Washington, D.C. trips. This is called a surcharge. They actually will build up soil in this area, which is equivalent about to the load of the future building. And so that will compress or consolidate the soil at the site. Then they take it back. It isn't done a lot, but it's done some. And then they take it away, and then they build their structure. So they don't get any what they call long-term consolidation or long-term settlement of the existing soil at the site. And this is an interesting one. These are pictures from Mack Hall. Now, when you come out of Mack Hall, you come out of, you've just eaten at Mack Hall. And God, do I miss $5 Fridays. So you come out of there and you're walking towards, say, the library. On your left is the baking lab. You've probably seen it. This is when they were rehabbing that room. I forgot what it was, and they made the baking lab out of it. Well, they did some coring through these slabs. Look at the gaps underneath the slabs. So what they had to do, they were putting piping in for floor drains for their sinks. And when they did that, they found all these gaps. In other words, the soil had consolidated. It had settled underneath that slab. And so what they did is they pumped grout after they put their piping in, right? They saw cut the slabs, put their piping in, backfilled the piping, and then concreted in here, and then drilled holes and put in almost like a slurry grout to fill these voids. So that really showed consolidation, or what they call long-term settlement. Okay. I thought hey, is McNally here? I already thought I let him in. Anybody seen him? Well, that was a dumb question. Okay, if it's not him, we'll put him in the waiting room. So that's kind of a synopsis of what goes on for the soil. Now, what you did is you let's see, you read these first few pages of this book online. Okay, so really now they're saying what is soil, and now they're talking about the grain size distribution, the classification. I just wanted to give you that theory as to what soil testing is done during design to see what the soil can handle in terms of building loads and potential drainage and frost action and so on. Okay. And so like I think I asked you to read these first 13 pages. So this is what we're gonna, here's the USC, Unified Soil Classification. Once we classify the soil and we determine that we can use it, then we get into compaction. So we're probably the end of next week, we'll talk about compaction. And then the soil testing for compaction. The soil testing for classification dealt with the sieve test and also a test called the hydrometer. Okay? And then eventually we get to soil compaction. And then the lab test for compaction is called the Proctor test. And then the field test uses the nuclear gauge or the old Roman sand cone, which I don't even think they show. They don't. But they do talk about the Roman roads. Okay. So if we go back to my PDFs. So here's a good flow chart. You have this. This is also on Vanco. And the soils flow chart right there, which is in the soils folder, which is at the top of the Vanco Hall. Whoops. Soil flow chart. Here we go. So this is kind of a synopsis of what we just talked about. Surface exploration, the survey. This is the GPS that our friend Kevin, who's a professional surveyor locally, comes and shows us. We'll bring him back a year from now, and you folks will be welcome to come and take a look at all the toys he uses for surveying. This is his robotic total station. So this thing is like R2-D2. It pivots on that tripod, and basically Kevin walks around with a this is the GPS rover, but he walks around with a prism pole, and that thing follows him. So it's just a one-man crew. So then we talked about subsurface exploration, the soil borings. That's from what we just said and what we just saw in that other handout. This is the flow chart. So the soil lab testing on the site borings and soil truck to the site. In other words, if you have to bring soil on site, you go to a gravel bank, and it's what we call engineered or screened soil. You have to test it to make sure that it's appropriate for the project. So if you're doing a road, you want a nice clean gravel. Again, we classify soils. What soils can we use? We got to go to the specs. And we break down soils into coarse-grained and what we call fine-grained soils. Fine-grained soils. We're going to talk about that in a minute. Okay. So here are the lab tests to classify. This is a stack of sieves or a nest of sieves. And it tells the grain size of the soil sample. Okay, because not every, if you take, now here they're screening, so they are screening according to sizes, but they're not all the same size. Some are very close, and that's what's known as a uniform gravel or a uniform sand. The hydrometer is for the fine-grained soils. Okay, this is for the fine-grained soils. And so we go to the specs, right? Is it the USC, the AASHTO, the New York State, the feds? And we say, is the soil satisfactory or is it unsatisfactory? Or another term that's used, it was used at Denver, is it select or is it non-select? Okay, so what I'm going to do over the weekend is I'm going to generate a PowerPoint very similar to the one that I did for coordinate geometry in surveying. And it's going to be a step-by-step process on how to run the sieve test. So I'm going to ask you again to review the sieve YouTube that is listed on Vanco. Okay, if you haven't, I think it's about a 15, 17 minute video. And then my PowerPoint will complement that. And you're going to have some sieve homework that I'll probably send you by the end of the weekend. And I would imagine that will probably be due, like I said, late Wednesday night, maybe even into Thursday. So again, we'll talk Tuesday night for this class at 7:30 for a Zoom. If you can't make it, that's fine. I'll record it and post it to YouTube. I'm up to 3 million hits. I'm making money. Okay. Again, lab test to classify, just the basics. Sieve, hydrometers for silts and clays, and liquid and plastic limits. It's called Atterberg limits. It's in other words, is the soil plastic like clay? I took that sample of Denver clay, wadded it up like a baseball, and then threw it against the lab wall. That's cohesive. Okay. And then soil classification, see soil handouts 1 and 2, which we're going to talk about in a minute. Here's the existing site before ET. There's the refrigeration building. Okay, this looks, you can see how this looks similar to this. And then that's where they put in those retaining walls, and they got into a compaction issue, and that's why they had to bury one and rip out the other. There's the manhole going up. These are in sections of manholes, risers, if you will. And so here's the fill for the roadway. So it was a cut for, they had to cut into the side bank for this retaining wall. But where the driveway is, you can see in the model, that's where they filled. And there was a little bit of fill on this corner of the building. Student made this for me, and I think I've shown that to you. And of course, on the back side of that building, it was about a 15 to 16 foot cut for that lower lab floor area. Okay. And then this, again, always come back to this. This, I'll tell you, this is probably going to help you the most for the soils exam in May. This is the Proctor test, the Proctor curve. There's your sheep's foot roller. There's your nuke. There's your Roman sand cone. I call it Roman because it's old and it rarely is used, if ever. And then just some equipment. Okay. Now, we talked about, oh, and here's a proof roller. We'll talk about that. Plate compactor attached to a backhoe. You can compact in tight spaces against a manhole. Now, again, we took samples from, the designer took samples from the test borings. But during construction, in those fill areas, you've got to sample the soil that is used to build up an area, which it could be a roadway base. You got to sample it. Could be coming from a conveyor belt right at the gravel yard. Or it could be coming from a dump truck, or what we call a belly dump. We'll talk about that. So again, use this to kind of get a feel for where in the process are we. Okay. So that takes us to handout number 1. And this is what I'm going to do over the weekend. Like I said, I'm going to get you a PowerPoint. And here's the breakdown of soils. So this sieve, see this sieve right here. So this sieve, if that had an opening that was 3 inches by 3 inches, in other words, you come in with a sample, I don't know, 5 pounds a sample, 10 pounds a sample. There's a specification that says how many pounds you gotta bring in to sample. So you're bringing in, say from that, from here, from the boring, or you're bringing in from, you know, a dump truck comes to the site or off the conveyor belt. If any of that soil is retained, in other words, if it doesn't go through a 3-inch sieve, then it is either a cobble or a boulder. And a boulder actually is anything that does not go through a sieve that has a 12-inch opening, 12-inch by 12-inch. In other words, it couldn't be this small of a sieve. Anything that goes through a sieve, a 3-inch sieve, but does not go through a number 4 sieve, not a 4-inch, a number 4 sieve. These are called gravels. And a number, see where it says 3-inch, and then it's called the number 4, the number 40, the number 100, the number 200. That, if it's a numbered sieve, let's say see the number 4 right there? You take that number and you square it. And that is the openings per square inch of this mesh. This is called a sieve mesh, right? Or a sieve screen. So a number 4 has 16 openings per square inch of that surface area. A number 10 has 100 openings. A number 40 has 1,600. How about a number 200? How many openings per square inch? And I know I put you all to sleep, and that's...
Is it 800?
Well, what's 200 squared? That's a test question in May. What's 200 squared?
400?
40,000.
40,000. 400. No, that's 200 times 2. That's not 200 squared.
Yeah, my bad. I thought of it. I was thinking off too fast.
So again, a number 40 sieve has 1,600 openings. So think of how small the soil particle has to be to go through a number 200 sieve. So any of the soil that goes through the 200 sieve is a silt or a clay. So if I go back to this, again, anything that goes through a 3-inch but is retained by the number 4 is a gravel. Any particle in that sample size that goes through the number 4 sieve but does not go through, or is what we call retained by the number 200, is a sand. And any part of the sample that goes through a number 200 is a silt or a clay. And clay is your smallest soil particle. Okay? It's your smallest soil particle. Now, the test that differentiates a silt from clay is the hydrometer and the plastic limit and liquid limit tests. Okay, so these are done on the fine grain portion of the soil sample. If it's all gravel, they're not going to run a hydrometer test or an Atterberg test, which is liquid and plastic limit. They're just going to run the sieve test. Right? If you have, say, less than 5% of the soil sample. Let's say you got a 100-pound sample. If only 5 pounds goes through the number 200 sieve, then that's 5%. That's what they call a clean gravel or a clean sand. So let's see here. Let's go back. So what I'm going to teach you how to do is, where'd it go? Okay, so this is the data sheet that I'm going to be putting on PowerPoint. So if you look at this data sheet, you're going to actually weigh the sieve. You're going to weigh it empty. You got the 3-inch sieve, the 2-inch, the 1-inch, the 3/4, and so on. 1/4 inch means the opening is 1/4 by 1/4. The number 4 means it has 16 openings per square inch. All the way down. Now the pan is the last thing in the stack of sieves. It's not a sieve. It literally catches the silts and clays. So, whoops. There, didn't know what that was. So you're going to weigh each of those sieves, right? And then you're going to have a sample size, say 1,000 grams, and you're going to, did I lose all my other, no. And so you're going to take that sample and you're going to pour it into the sieve, and they're in descending sizes. So you pour it into you pour that in, and then you put it in a shaker, which you've seen if you watch the video. And then you take it out of the shaker, and then you're going to weigh it, but now it's got soil in it. So see these right here? Column 4 is column 3 minus column 2. So I'm going to give you the data. I'm going to give you the weight of the original sample. I'm going to give you the weight of the sieves, and I'm going to give you the weight of the sieve plus the soil. So if you subtract the weight of the empty sieve from the combined weight of the sieve plus the soil, you now have just the weight of the soil retained. So all of these sieves, or all of these now have this is just the weight of the soil retained, and you add all those up, and the summation of this column has to be equal to what? Your original sample size. And then the rest of the calcs, this shows you how to do it, and I'm going to show you examples. So, and then what you do is this right here, which is the percent passing. If you take a look at this graph, this is at 90 degrees. So now there's the percent passing the number, that's column 7 from your data sheet, and here's your grain size. Put this down here. So if you take a look at this, this is a logarithmic curve, right? So these are the grain size in millimeters, and these are the sieve openings and the sieve numbers. So there's that number 4 sieve we talked about. There's the number 200. There's the 3-inch sieve, okay? And 1 inch is about 25.4 millimeters, okay? So there's 10, 20, 30, 40, 50, and it's logarithmic, so it's not an even increment along here. So you're going to take this data from here, and then you're going to graph it. And once you do that, that's going to tell you, you got to go back to viewing it the right way. Let's see, was there another? Where's soil? Yeah, so if you take a look at this one, this is on soil handout number 1. And there's like, that's what they call the soil curve. Okay, so these curves right here are what you read about right here. Okay, so there was your sieve size, and this is actually a mirror image. They're going from their biggest sieve right to left. Our graph is left to right. Okay, so you want to read this again. Just read pages 1 through, say, 8. And that's going to help you. 1 through 8 is on classification. It's going to give you a good description as to, excuse me, why we're classifying soils. Okay. So we've thrown a lot of information at you. It is frustrating that we can't do this in the lab, because then I've got this stuff right in front of you. I pass it around so that you can, you can see this stuff. It makes a lot more sense, and that's what I'm going to try to do with the PowerPoint. Okay. Now, so I'll make a list of all the reading that you got to do. It's not a lot. Again, page 1 through 8 now talks about classification. Okay, talks about the sieve. There's the sieve shaker. Shakes the living bejesus out of that thing. And so all the particles start to fall until they hit a sieve that has a mesh that is, say, smaller than the particle size. So the particle size cannot go any further down the stack of sieves. Again, if you have clay, you really can't use this. You've got to go with a hydrometer or the plastic and liquid limit. Now, the plastic limit, real quick, when I talk about that, let me find that here. This is the plastic limit. Actually, this is the liquid limit. This is the plastic. All that is the water content for the liquid limit that makes the soil move like lava. Okay? Makes it move like lava. And let's see, the mudslide. So this is a 37-second. So that is a mudslide in Norway in the 50s. The clay, the marine clay, hit a certain moisture level, and somebody started excavating in that area, and that's what happened. Isn't that amazing? Unfortunately, one person died, but you would think a lot more would have. And that's liquid limit. That's the moisture content that soil moves like lava. And there was also a much longer YouTube on that. So we went over a little bit. I appreciate your patience. Just to recap, heavy civil exam tomorrow night. The test opens up at 7. It ends at 11. And it is, now you won't be able to see it now, but it's right there. It's at the beginning of Vanco Hall. It's all multiple choice, true, false. It's a lot of identification. There's some estimating. Okay. And what else did I tell you? I think that was about it. Oh, I put easy questions just to make it easy. I put some questions on the column lines of the ET mockup in Smith Lab 10. Remember column line 2, column line F, column line D.4, column line G. There's some identification of those column lines. That's a gimme. I figured it snowed the other day, made me feel like Christmas and Santa Claus, so I figured I'd throw some easy questions on there. So that's the only thing that is not masonry, okay? So just pass the word. And let me, ET column lines. Okay, ET column lines. Okay, surveying, exam, Monday night, starting at, again, 7. We'll go 7 to 11 with a 2-hour block. I will be sending out an email about that probably by tomorrow. So now I'm just going through my list to make, and so I'm going to pause recording. We're talking about assignments. You really want to check Vanco for every single course once or twice a day. I know this whole scenario has been, it's harder on you folks. And, but if you check that every single day, and if you catch me in a mistake, actually, I kind of like that because it shows me that you're paying attention. It doesn't bother me if, I'll make it right. But for heaven's sakes, read it. And ask specific questions and watch your emails, okay? Don't get snippy in your emails. I know everybody's, it's a tough time. I've got to watch it too. And so always remember, before you hit the send button, are you willing to have that email published on the front page of the Wall Street Journal? And that's years ago, my boss gave me that helpful hint. So watch your emails. Okay. So good luck on the test tomorrow. Good luck on the test on Monday in surveying. And I will definitely be in touch with some information for you. Any other questions? I hope, as always, I should have started out the meeting. I hope that you and your families are all well, and wish the best for you. And we'll go from there. Okay, I'm going to stop the recording for Thursday, April 23rd. It's now 7:40. Take care, everybody.
Thank you.
Thanks for your patience. I appreciate it.